Hello guys, today we'll be discussing about Turing machines. Turing machine was invented by Sir Alan Turing in the year 1936. Turing machine is a simple mathematical model of a general purpose computer. It is capable of performing any calculation which can be performed by any computing machine. As we all know, the class of languages accepted by finite state automata is called regular languages, and the class of languages accepted by pushed-on automata is context-free languages. But the class of languages accepted by Turing machine is called recursively enumerable languages. You might be wondering, what is a recursively enumerable language? A language L is said to be recursively enumerable if there exists a Turing machine that accepts it. Now, we all know the data structure used for finite state automata is the input string, and the data structure used for pushed-on automata is the input string as well as the stack. But here, in a Turing machine, the data structure used is a tape. So what is a tape? A tape is a sequence of infinite symbols. Here, the dot represents that the tape is extended infinitely towards the left as well as towards the right. It also has a tape head, or also known as a read-write head. Tape head is situated where the current control is present. The tape head can move either to the left or either to the right. Now let us move towards the control unit. So, as the diagram you are seeing here, this is how a Turing machine looks like when working internally. The control unit is similar. Please mark my words, it is just similar, not equal to the finite state automata or pushed-on automata. Now this is the portion that is controlling the Turing machine. The control unit is totally deterministic. Let us discuss more about the tape. As I already told you, the tape has no boundaries and it is of infinite length, which stretch towards the left as well as towards the right. And it has a read-write head that moves towards the left and towards the right. So, what are the operations that a tape can perform? First one, the reads or scans the symbol. Second, writes or updates the symbol. Third, move towards the right or towards the left. For example, if here is a symbol, now the first operation is reading it or scanning it, the symbol. The second operation, write or updating the symbol with another symbol, and then moving towards the left or towards the right. For example, let us take the string A, B, A, and C. The tape head is pointing towards A. So the first operation reads A. Now A is read by the tape. Second, writes K. Now A is being updated by K. So now A is not here, but K, it is updated by K. Moves left, and now the tape moves left and now is pointing to the symbol B. Now we have another transition for B. Now the tape is currently pointing towards B. Now it reads B. Now what was our first operation? That is reading. Now it will again read B, and the operation is write F. Now it will update the value of B with F. So B is being updated with F in time 2 and move towards the right. So now again the tape head is pointing to K. We all know that A is being already updated to K, so the tape head is pointing to K. The input string. You might be wondering, what are these blank symbols here? The blank symbols are nothing but whenever a machine encounters a blank symbol, it halts. We can also say that if there is a no symbol in a cell, it is represented by a blank symbol only. Here we have the string A, B, A, and C. Here is the head. Please note that the head always starts with the leftmost position of the input string. The blank symbol are treated as left and right brackets for the input written on the tape. States and transition of Turing machine. Here we have the diagram which represents the transition diagram of a Turing machine. Q1 and Q2 are states. Now let's see how this goes on. A. A is the symbol which is to be read by the machine. B. B is the symbol which is to be write by the machine, and L or R is the will be the symbol the machine will be telling to the tape head which will move left or to the right. Now what if we don't want to update the cell? So simply we can just update with the same value. For example, here as A is being updated to B, but here we can write A is being updated to A itself. So this will not make any change. Now for example, in time 1 we have the string A, B, A and C. Now Q1 is the current state and the transition function is A is being updated to B now, and the tape head shifts towards the right. So in time 2 A is being updated to B and the tape head shift towards C. Now here is another example. In the string A, B, A and C, the in the string A, B, A and C, the initial state is Q1 and the tape head is pointing to A, and we have the transition function. A is being updated by B and the tape head will shift towards the left. So we can see in time 2 A is being updated to B and the tape head now shifts to left and now points to B. Determinism. So Turing machines are deterministic. Here in this diagram we can see that there are three states Q1, Q2 and Q3. Now Q1 is leading to Q2 as well as to Q3, but the transition states are A is being updated to B with and the tape head shifts towards the right. Here B is being updated to D and the tape head shifts towards the left. Now in this diagram you can see that A is being updated to B as well as the A is being updated to D. So how is it possible? So this non-determinism is not at all possible in Turing machines. Please note that no lambda transitions are allowed. Partial transition function. Now partial transition function is when there is no transition for an input symbol, and that is perfectly okay for a Turing machine. If we want to give no transition for an input symbol, as we can see here, there are no transition for the input symbol C. There are three states Q1, Q2 and Q3, and the transition for A is being updated to B with a shift of right, and B is being updated to D with a shift of left. Okay, so there are no transition for C. So what will happen when the tape head reaches C? It will come to an halt. We'll see it later in the video. Halting. The machine halts if there are no possible transition to follow. Now let us see the example of halting. The same example, we have the string A, B, A and C, and we have the transitions for A and we have the transition for B as well, but we don't have the transition for C, and the tape head is pointing to C. So now what to do? So as there are no possible transition, the machine will halt. Final states. We'll discuss about some states. Now Q1 is the initial state here and Q2 is the final state. Now this is allowed in the Turing machine. Now and you can, in this diagram, Q1 is the final state and Q2 is the non-final state. This is not allowed because the final states have no outgoing transition in a Turing machine. Please remember, finite states have no outgoing transition in Turing machine. In a final state, the machine halts. Acceptance. So the input is accepted if the machine halts in a finite state. Please remember, our input is accepted if the machine halts in a final state. Now our input is rejected if a machine halts in a non-final state, or we can say that the machine enters an infinite loop. So the machine will never come out or never accept the input. It will go on an infinite loop. Okay. Turing machine example. Let us see an example of the Turing machine. A Turing machine that accepts the language AA star. Now what is the meaning of AA star? AA star means at least there is one A and then there can be number of A's. Here is the solution, but we will now see how is it done. Okay, so in time 0, let us take an input string of 3 A's, A and A. Now as we have already discussed, the tape head always points towards the leftmost input symbol. So here is the tape head and here is the initial state Q0 and Q1 is the final state. So on Q0, the transition function is A is being updated to A with a shift of right. Okay, So that means there is no change in the input symbol. A is being updated by itself only, and the tape head moves to right. So now our tape head is here. Now our tape head will come here to the right here. In time 1, the tape head points here. And now again, it is only the state is not being changed. So it is only in Q0 state. So now again the transition function A is being updated to A, and the tape head moves to right. So updation with A itself doesn't make any change, and the head moves to the right. So in time 2, the head moves to the right, and now it is also encountering A. So we have the same function. A is being updated to A with a shift of right. So our tape head comes here, but here is the blank symbol. So we have a transition for blank symbol as well. So whenever the tape encounters a blank symbol, it will not change anything, and then the tape head shift towards the left. So the tape head will again come here, and this will be our final state, and the string will be accepted. So our string is accepted. Now the machine will halt, and our string is accepted. Thank you.